Today we're going to integrate algebra with our graphing analysis to answer questions. So we're going to tie into what we already know. Given the given function, so notice we're given f of x, determine all of the intervals on which f is decreasing. So one key idea here is that a decreasing function, there's two choices. It's either going to look like this, or it's going to look like this. Okay, in this case, we know that f prime is negative. All right. So keeping that in mind, the algebra is going to support that conclusion. We're going to take the derivative so we can work with the slopes. We're going to determine a function that relates x to its slope. From here, we're going to determine what we call the critical points. We get that by taking the factored form of the f prime function, setting it equal to 0, and when we do that, 3x equals 0 yields a critical point of 0. X minus 2 equal to 0 yields a critical point of 2. Now, remember, these are inputs. If I plug in x of 0, that makes the right side equal to 0. Okay, so on the graph of f, these are the two places where the slope is 0, which would be found at the mountaintops or the valleys where slope is 0. Now, if we want to talk about what is the sign of the slope at any given time, we can come over here and say, okay, if I plug 3 back into the slope function in its factored form, I'm going to get a positive 9, and I'm going to get a positive 1. Positive times a positive yields a positive. Now, most of the time, we're not going to do the exact calculation. We can just use our sign rules. So, for example, if I choose the number 1, which falls between 0 and 2, I'm going to get positive 3 times negative 1. How did I come up with the negative? Right here, 1 minus 2 is negative 1. So overall, my sign region is negative. Then lastly, I can move over here to negative 1, plug it in, I get a negative times a negative, which gives me a positive for this region. I'm looking for where f prime, so this is my f prime number line, is negative. So my answer then would be on the interval between 0 and 2, I would have a negative slope. Now, as you're taking notes on these problems, please note that these 4 examples are also reassigned to you in the Delta Math assignment itself. So you should get 4 problems correct, in other words. Now, find all of the x-coordinates of the relative maxima. So let's break this down. Relative maxima are going to be the mountaintops. The mountaintops have slope, so if I'm talking about f prime, that's positive, followed by negative. And we want to find the x-coordinates of that situation. So from here, what we're going to do is we are going to take the derivative, we're going to factor the derivative by GCFing out a 2x, continue to binomial factor. This is going to yield 3 different critical points. So my critical points are going to be from the first is a 0, from the second is 4, and from the third is 2, which means I have 4 different regions to check. If I plug a 5 in on the far right, I get positive, positive, positive. If I plug a 3 in, positive, negative, positive. Plug a 1 in, positive, negative, negative. And plug a negative 1 in, negative, negative, negative. If you remember, the relative max should have a positive slope followed by a negative slope. That only happens here, which means when x equals 2, I have a relative maximum because the slope changes from positive to negative. All right, next two problems. Given a function, find all the values, x values, where f has an inflection point. So this is a new vocabulary. From the video, inflection points are going to exist relative to f double prime. On the graph of f, so if I'm looking at f's graph, okay, an inflection point is going to occur when we go from concave down to concave up, or from concave up to concave down. Okay, let me pull this down so you can see that. Concave down to up to down. Okay, so these would be inflection points. The slope remains the same, positive, or in this case, negative. But at this key point, this is where the concavity changes. So what I'm going to do is I'm first going to find f prime of x. It's going to be 1/2 x to the 4th minus 8x to the 3rd plus 36x squared. My f double prime of x, because remember we're going to talk about inflection points, is going to be 2x to the 3rd minus 24x squared plus 72x, which then I'm going to factor. All right. From here, this is going to yield only 2. Inflection points to check. All right, this is what we used to call in pre-calc a double root. Interestingly, on an even, there are 2 of them even. There are 4 of them even. There are 6 of them even. Anytime you have a factor repeated twice, or 4 times, or 6 times, etc., this is a double root. Okay. When we go back to our checking procedure, if I plug a 7 in, I'm going to get 3 positives. If I plug a 1 in, I'm going to get positive, negative, negative. Notice that there's no sign flip on either side. It stays the same. That's one of the features of a double root. If I plug in -1, I'm going to get negatives across the board. All right, we're looking for an inflection point. An inflection point is a change in concavity that only exists right here. So my inflection point has an x value of 0. All right, for my last example, we're looking for 2 things. We're looking for where a function is increasing. All right, so that means that f prime is positive. But then we're also looking for concave down. So we're looking for where f prime is negative. Concave down has 2 parts to it. Take a look. Okay, this or this, which we have to choose from. So the question is, which of these is an increasing slope? That's this one. Okay, now, in case you forgot and you didn't write this down, this was a chart that I printed out from the video. Okay, so here's your concave down, here's your concave up. You can talk about f prime, you can talk about f double prime. Right? This chart's really, really handy with what we're going to do. So I can think it out this way. I always start with concavity, limit the chart down to 2, and then I answer questions from there. But I'm going to need both of these, f prime number line and an f double prime number line. So if I start with f prime, I'm going to take my derivative, -4x to the 3rd. Notice again I have this existence of my double root. So when I set up my number line and I look at 0 and -3, this is my double root. checking my signs, checking my regions, this is what I get. Negative, positive, positive. Okay? Then I can come down here and I can do f double prime of x. Minus 36. Okay, this is going to yield only 2 critical values. Negative 12 is not a critical value. We do want it there. We want to use it in our calculation, but it is not a critical value. So the 2 critical values I'm going to get are negative 3 and negative 1. Okay, if I check over here to the right, a 0, which is to the right of negative 1, I get negative 12 times positive 3 times positive. And the sign of this should be negative. Negative, positive, positive. Then I can check in the middle here with negative 2, negative 12, positive, negative. And then I can check negative 4. Negative 12, negative, negative, yields a negative. Okay? Now, this is the interesting part. This was our criteria that we were looking for up here at the top. So I'm going to draw one number line. And I'm going to put the first f prime on top. So here's negative 3. Here's 0. Negative. Anything in here is positive. Anything over here is positive. Okay? But notice down here, negative 3 is the same. So to the left of negative 3, I have negatives right here. Between negative 3 and negative 1, so what I'm going to do is I'm going to put my negative 1 on. Negative 3 to negative 1, I have a positive here. But what about between negative 1 and 0 up top? Well, because we added that in there, it still is a positive region. Like this whole thing was positive before, so each piece is now positive. Between negative 1 and 0, I should have a negative. You can see that here, and a negative. So my bottom row is f double prime, and my top row is f prime. And what I'm looking for is, look, these are the signs of the regions. So I'm going to make this a little bit more pronounced, my divisions. What I'm looking for then is where I have f prime positive, so I have these 3 choices, or f double prime is negative. That to me exists in 2 areas, here and here. So my final solution is on the interval from negative infinity to negative 3, union with negative 1 to 0. Final answer.